Welcome back. I'm Stuart Harrington, and this is the practice session for module number 5. Just to give you a quick review of what we covered in the content portion of this video, take a look at this objective. It is very simple, calculating the rate of change of a linear function represented by a table, by a graph, or a linear function. That's all we did. We worked 3 kinds of problems. We had some vocabulary that we looked at. We talked about the rate of change. We talked about the graph, the table, and the linear function. And we also talked about that fancy word algebraically, what that is referencing when we use that in a mathematical context. So let's dive right in and take a look at the kinds of problems we worked so that you can practice on that skill. Remember that as we do these problems, we're going to use our pause, work, resume, and compare strategy, where you will pause your video, do your work, get your answer, hit resume, and compare that to what we have done on the screen. So let's dive right into problem number 1. Our first problem is going to involve a table. We've got some data here in this table. We're going to compare the value of a coin that you may have purchased at a coin shop. And when you first purchased that coin was valued at $10. And you're going to hang on to that coin and keep that coin so that it increases in value over time. And the projection is that in 4 years, that coin is going to be worth $50. And then in 10 years, the coin is going to be worth $110. That table of values, we want to calculate what is the rate of change for that coin value. Now, I've left the formula for the slope there on the screen. That would be something that you might want to start committing to memory, though, because that could disappear at some point and not be available to you. So you don't want to become dependent upon that formula being visible all the time. But we'll leave it up there for a little bit, and let's talk about this table. Now, we spoke in the content portion about how we look at a table and we're actually looking at points. 0, 10, 450, 10, 110. And any of these can be point 1 or point 2. You decide which one you want to be point 2 and point 1. Work the problem out and then come back and let's see how you did. Go ahead and pause your video. Welcome back. How did you do? Hopefully you were able to come up with an answer. Now, in looking at this problem, I'm simply going to say this is my second point and this is my first point. Maybe that's what you did too. If you didn't, that's okay. Let's wait till we get the answer at the end to see if you calculated correctly. So I want the y value of my second point. The y value of my second point is going to be 50. And then the y value of my first point is going to be 10. So 50 minus 10 is what I'm going to have on the top of my fraction. The x value of my second point is going to be 4 minus the x value of my first point. That's going to be 0. So consequently, we will have 40 over 4, which is going to be equal to 10 when it reduces. So what is the rate of change? It is going to be 10 to 1. Okay, that's the slope, 10 over 1. 10 to 1 is going to be the rate of change. The change of the money is going to be changing by 10 each time the year changes by 1. The change of the y value is 10 for every 1 year of change. That is what we're talking about for this particular problem. Hopefully you did well on that. If you did not get the same answer and you chose a different number 1 or number 2 point, go back and check your mathematics, all right, your calculations, because you've got an error there. You either added or subtracted incorrectly, or you plugged the numbers for your points into the wrong locations of the formula. All right, let's go on to our next problem. On this one, we're going to be looking at a graph. We want to find the rate of change that is represented by this picture. We can do it two ways. We can either count the spaces on the graph, or we can use our formula. Identify a couple of points and use the formula for slope that we have on the screen. Now, I will work it both ways when we get back together, but I want you to find the rate of change for the graph represented here. Hit pause. Welcome back. Let's take a look at this particular graph. Now this graph is going down. If I look at the right side of the graph, it's pointed downward. So the rate of change that I'm expecting to get here is negative. If I don't get a negative answer, I need to go back and check my work because I've done something incorrectly. So let's take a look, first of all, by looking at these points. We're going to label this point up here point number 1, and this one down here as point number 2. So the coordinates of point number 1 are -4, 4, and the coordinates of point number 2 are 2, -3. And I'm simply getting that from the graph here. I'm just looking at the values, okay? So, plugging those into my formula. The y value of the second point, remember this is our second point, and this is our first point. The y value of the second point is -3. The y value of the first point is 4, and we're subtracting that. Now on the x's, the x value of the second point is 2, minus the x value of the first point, -4. Oh, I'm so glad this worked out like this. Because remember, the formula says subtract, minus. And then it just so happened that for this problem, the x value of the first coordinate was negative. So that's minus negative. Please don't forget that. Otherwise, you will get an incorrect answer. So I'm going to do my calculations now. -3 and a -4. That's what -3 minus 4 means. -3 plus -4. That's going to be -7. And then we're going to have 2 minus -4. Remember that means plus +4. So 2 plus 4 is really 6. So there's the slope of that line. And remember, the slope is the same thing as the rate of change. So the rate of change is -7 to 6. It was negative, wasn't it? It did turn out to be negative. That's a good thing because that is what we expected. Now, what if I just wanted to count the spaces? I didn't want to mess with, what's the name of this point or what's the name of that point or whatever. I'm just wanting to look at the graph and figure out how does the y value change compared to the x value. So let's look for delta y divided by delta x. The y value changes if we're going from right here to right here. The y value starts at 4 and goes all the way down to right here. How far is that? 1, 2, 3, 4, 5, 6, 7. And it's 7 down. So that's going to be -7. What does the x value do? The x value comes right from here and goes all the way to here. How far is that? 1, 2, 3, 4, 5, 6 to the right. So that is a +6. And look at that. Again, we get -7 over 6. So our rate of change is still -7 over 6. Okay, -7 to 6. It's the same answer. Hope you did well on that one. Let's continue on with another graph. All right, here's our next problem. Look at this graph. We're looking for the rate of change of this line. Hit the pause button and let's see how you do. All right, welcome back. Let's see how you did. So we're going to identify these points, plug them into our formula, and go. This one's going to be point number 1 up here, and this one down here will be our number 2 point. All right? So the number 1 point is going to have the name 0, 6, And point number 2 is going to be -4, 0. By the way, quick review. What's the special descriptive name of this point right here, point number 1? It's the y-intercept. And what about this guy? That's the x-intercept, the 0. Just a free trivia question from a previous module. Let's go ahead and resume plugging these values into our formula. What are our y2 minus y1 values? The y value of the second point is 0 minus y value of the first point, that is 6. The x of the second point is -4 minus the x of the first point, which is 0. That is going to be equal to -6 over -4. Negative divided by a negative is positive, and then that reduces to 3 over 2. So we got our positive rate of change, but we anticipated that. We had to reduce the fraction a little bit, but it worked out pretty easily. And our ROC is 3 to 2. Okay, rate of change, 3 to 2. Hopefully you don't have any questions over that. Hopefully you got it correct. Now, if you did that by counting spaces, what would that have looked like? Using the counting spaces method, remember what we are trying to find is what is the change of y divided by the change of x. What are the y values doing? Here to here. If we start with this point, number 1, and go to this point, number 2, what does the y value do? It has to go up 1, 2, 3, 4, 5, 6 spots. Up 6 is positive 6. And what is the x value doing? It goes from right here to right here. That's 1, 2, 3, 4. That's a positive 4 because it is 4 to the right. And so we have 6 over 4, which reduces to 3 over 2. Still get the same ROC, 3 to 2. Doesn't matter if you use the counting spaces method or if you use the formula. That's your choice, whichever one you feel more comfortable with. Just make sure you do the math right, whichever one you choose. All right? Very good. Let's carry on to the next problem. Our next problems are going to be algebraic equations. We're not going to be looking at graphs and tables. We've already practiced those. Let's look at some algebraic equations. So the first one is right here. If I look at this equation, I need to decide what is the slope of this line. We need to be reminded, and we'll sort of do it up here in the corner, real small, that we need to know what is y equals mx plus b. We are looking at the slope-intercept form of the equation so that we can identify the slope of the line. Now, this particular equation in this problem is already done for us. It's already in slope-intercept form, and so hopefully you would be able to say what is in the m slot. Well, that's this fraction right here, 3/5. So the ROC of this is going to be 3/5. That doesn't take much work at all. Okay, so anytime you're in slope-intercept form, you can just read the problem and figure out what the slope is and know that that's your ROC. But what if that's not the case? What if we have another situation where instead of this nice, friendly equation that we have that's already in slope form, what if we have this? How are you going to do this problem? Hit the pause button and let's see if you get the right answer. All right, welcome back. Let's see how you did. We cannot just look at what's in front of the x to get the slope when it's not in slope form. We have to work on this problem until it looks like this in its format, which means we've got to work on it until we get down here and we have y equals something. We're not done until we get y equals something. So that means I've got this 2x that's got to go away, and I've got this 5 that needs to go away in order to have the y all by itself. So let's get after that. First thing we're going to do is subtract that 2x. We got to get rid of that friend. Minus 2x on both sides. And we're going to cancel those guys out, and that will leave us with the 5y equal to a negative 2x plus 10. Now we're almost done. We've got to divide by 5 to get the y by itself. Those 5's will cancel out, and we'll have y all alone just like we want it to be. Okay? Now what happens over here, though? We've got to divide by 5 on this side as well. Keep in mind that this 5 has to divide into the 2x, and it's got to divide into the 10 both. So 5 and 2, that doesn't divide evenly, so that's simply going to be the negative 2/5 x, and then plus, what's 10 divided by 5 going to be? That's going to be 2, so we'll have that. So now we've got it in slope-intercept form. What is the slope? The slope is this negative 2/5. Therefore, the rate of change is negative 2 to 5. Negative 2 to 5. Hopefully that's what you got for your answer. Let's put another equation on the screen for you. All right, take a look at this friend. Again, not in slope-intercept form. We have to do some algebra to make this work. We have to get it to a point where it says y equals something. So we've got y equals something. How are we going to make that happen? Well, I have to take this 4x and get rid of it. I have to get rid of negative 2 as well. So let's subtract the 4x from both sides, like so. That's going to get rid of it from this side, and I'll be left with negative 2y equals negative 4x plus 7. Finish it off by dividing by negative 2. Cancels there. Gets us with the y all by itself, which is what we're hoping for. What's happening over here, though? We've got to divide this one by negative 2 as well. Remember, the negative 2 goes into both pieces. Negative 4 divided by negative 2, that's going to be a positive 2. Positive 7 divided by negative 2 is going to be negative, and we'll just leave it as 7 over 2. You can change that to 3.5 if you want to, but in algebra we don't really worry about mixed numbers anymore. Used to be a situation where every time you had an improper fraction, which is what 7 over 2 is, but we don't have to change those to mixed numbers anymore. We can just leave them. So 7 over 2 is where you can leave that answer. So what is the slope of this line? The slope of this line is now 2. M is going to equal 2. So what is the rate of change? All right. Our ROC is going to be 2 to 1. 2 to 1 for our rate of change. Last problem. Here it comes. Look at this thing. 4y minus 3x equals negative 12. This one looks a little bit different, and that's why I wanted to make sure it was in the samples for us. The x and the y are in different slots. What does that mean? That doesn't mean anything. That just means we've still got to do the same work because we have to fix the problem so that it boils down to y equals something times x plus b. The order that we're given the terms in doesn't matter. So I've got to get rid of minus 3x, and I have to get rid of 4. How do I get rid of minus 3x? Well, to make that go away, I'm going to say plus 3x. We haven't seen one like that, but it can certainly happen. Plus 3x on both sides, and so I get 4y equals 3x minus 12. And then the next step, I got to get the y by itself, so I got to get rid of 4. So I'm simply going to divide by 4. Divide by 4 right there. Both of those friends cancel out, and we get the y value. What about dividing by 4 over here? 4 has to go into both terms. 3 divided by 4, that's just a fraction that doesn't reduce. So we'll have 3/4 x. And then negative 12 divided by 4 is going to be negative 3. So we're going to put minus 3 right there. So my slope is going to be 3/4 based on this equation, because that's what's in the m position. All right, m position is 3/4. So our ROC is 3 to 4. 3 to 4. All right, that completes our work on these practice problems. And what we've got to look at now is, how did you do? If you worked through these and you did very well, then it's very possible that you understand exactly what's happening. If you made some errors, why would that happen? Possibly because you're switching the x and the y value in slope computation. You're putting delta x on top of delta y. That's not how it works. The y changes go in the numerator. The x changes go down in the lower part of the fraction, the denominator. So that might be a reason you're not doing well. You might also be making errors on your calculations. That still is part of the game. If you are inaccurately adding and subtracting positive and negative numbers, you're just not going to get correct answers. It's just not going to happen. The other thing that can play a part in getting these problems correct is paying attention to the scale. Remember those graphs we had that some of them were every 100, all right? And then across the bottom it went 2, 4, 6, 8 or whatever. So you've got to pay attention to the scale that you're working on when you're looking at your graphs. Some of those things might create errors in your work. So if you got through these problems and you believe that you're ready to go take the little assessment, you may do that. If you need a little more instruction, that's video 1. If you want to go back and take a look at this video and review some of the problems, you're certainly free to do that. So let's go ahead and dismiss this video, and we'll see you next time. Bye-bye.